Now that you've had a chance to work through programming some models that have what might be critical components of consciousness, let's zoom out to talk about what we've actually accomplished. In particular, we've learned about some theories and learned how to program some of the computations those theories think are important into some toy simulations. But are these the right ones? What other theories might be out there that might be right? What are we missing, theoretically or just in the data we're collecting? How do we know which theory is right or even promising? How can we tell which theories of consciousness are doomed from the outset so we don't go trying to program those components into AI to make it have consciousness, if that's even a good idea at all? So to help close out our discussion of theories and ways of studying consciousness from a scientific perspective in general, and to help keep you thinking about how the theoretical study of consciousness from a neuroscientific and computational standpoint relates very much to how we should build neuro-inspired AI, let's hear from Hakwon Lau, team leader of the Laboratory for Consciousness in the Center for Brain Science at RIKEN in Tokyo.
So now you have seen the theories. What do you think? In general, throughout this course, you have probably seen how we evaluate theories using data. That is to say, we shouldn't judge a theory based on how cool it sounds from the outset. If they don't fit the data, they are no good. But what data are relevant here? Well, as we talked about earlier, the critical data comes from experiments in which we vary or compare different levels of consciousness, that is, subjective experience, while we hold other automatic or non-conscious processes constant. The latter part is really important. Without controlling for that, we have an experimental confound. It may be very basic to explain, but I think you all know this. It's like if you want to see if tall people are more intelligent than short people, if you found that short people are in fact more intelligent in your data, well, you have to check if that is only because in the group of subjects you tested, height is correlated with gender. Maybe that is the only reason why you see the pattern of data. Maybe it's just that women scored higher on that particular test of intelligence in your data. So if you control for gender, maybe the effect would just be gone. Unfortunately, most of the studies currently used to evaluate theories of consciousness are highly confounded. And when I say most, I really mean something like more than 99% of all the published studies. So it's basically prevalent in every study, in most of the studies you would come across. For example, in clinical studies, people may compare subjects in a normal wakeful state with patients in a coma. So certainly consciousness differs between these groups. So when you actually look at them, of course, consciousness differs, but so does general cognition. The patients in coma presumably lack conscious experiences, but they are also not talking, walking around, thinking about things, responding to external stimuli, etc. So in a comparison between these two groups, it's fine for clinical purposes, for understanding the conditions that the patients are in. But for the purpose of evaluating theories of consciousness, these results are basically useless. And yet, most theorists would happily claim that these results support their own theories. This is, in fact, quite a shocking problem in terms of how prevalent it is, and also about how plausible the alternative explanation is, given the confounds. To play devil's advocate a bit, one may summarize most of these theories as saying that, well, when we have conscious experiences, our brain just works as it should. In other words, according to these theories, consciousness is just brain processes that are global, stable, deeper, more complex, more recurrent, more involved somehow. But of course, this may just be how cognition works and how perception works, regardless of consciousness. These may be just the conditions that you need for having good signals for effective information processing in the brain. So we use these clinical studies for as a basis for evaluating theories, if we do that, we'll be in real trouble. We will get the illusion that most of these theories are supported by the results, but really they are just supported by the confounds of general cognition. Now, of course, if you think about it, it doesn't just apply to cognition and clinical studies. It also applies to perception studies as well. Now that you have learned that blind sight, you've learned about it, you realize that it is a very rare condition. Most studies of conscious perception are not like that at all. When people use vision psychophysics to try to render some stimuli invisible, say by using backward masking or binocular suppression, that is flashing something to one eye and suppress the content presented to the other. In all of these ways of rendering things invisible, usually, not only is conscious experience gone, perception is also mostly gone. It's nothing like blind sight at all. There is basically in blind sight, there is so much perceptual processing still going on, even though it's not conscious. But in most of these manipulations, when you render the stimuli non-conscious, basically the perception is basically gone. So in other words, in most of these studies, not just clinical studies, there's also a huge confound, and the confound here is perception in general. So these studies may be just comparing perception versus very little perception, but it's not really about consciousness per se. Given this, which of these theories that you've just learned about do you think really survives? That is to say, which of these theories really explain something like blind sight? Which of these theories are just driven by confounds? Or in other words, which of these are really theories of consciousness specifically, that is about subjective experience, and which of these are just general descriptions of brain functioning, capable of cognition and perception? Given how damning this problem is, why do you think researchers haven't fixed it yet? Because the fix doesn't seem very complicated. Why don't we just focus on studies of blind sight and studies like that, where the manipulation of subjective experience or consciousness is not confounded? Why would they include all these other highly confounded, obviously confounded studies when they evaluate their theories? I'll let you think about this for a bit, and I might come back to this near the end.
Now that we've heard from Hak-Wan, let's do a final discussion activity. Heading into our breakout rooms, in room 1, you'll discuss what are some functions or capacities associated with consciousness in humans that you programmed into your simulations. Do you think those programmed functions target phenomenal consciousness? Why or why not? If you'd like to instead discuss in room 2, you can discuss whether you think the hard problem of consciousness is compelling. Why or why not? Think about your simulations here too.